All right, today we are doing a deep dive into the heart of, well, modern media logistics. We're focusing on one really fascinating piece of hardware, the Thor Broadcast H-8QAM-IP gateway.
It's a key piece of the puzzle for a lot of operators.
It really is. So for you listening, just imagine for a second you're running a huge operation, maybe a university campus, a cruise ship, a new hotel.
Right, anywhere with a ton of screens.
Exactly, and you're trying to get TV signals everywhere, but they're coming in from all over. You've got traditional cable, satellite dish, local over-the-air broadcasts. Your biggest headache is turning that complete mess into one standard format.
One format that works on every single TV, whether it's an old coaxial connection or a modern IPTV network.
Okay, so let's unpack this thing. The core mission of this box, the H-8QAM-IP, is basically translation. It takes these very specific radio frequency signals, in this case, the DVB-C QAM standard, which is digital cable, and it converts them into standard internet protocol, or IP, streams. Think of it like a currency exchange for your video feeds.
And what's really fascinating here is that it's not just a one-way street. It's not just a simple converter. It has a really powerful transmodulator function.
Oh, okay. So what does that mean?
It means it can take signals from, say, ATSC or DVB-T, those are common for over-the-air broadcasts, and convert them to IP, yes, but it can also convert them back to QAM.
Wow.
I mean, that capability just changes the entire logistics of how you distribute content. Operators can now, easily grab free local channels from an antenna and just inject them right into their closed QAM cable system.
So you could build a whole new channel lineup without buying all new infrastructure.
You can rearrange everything, shift frequencies, add channels. It's incredibly flexible.
So it's globally fluent then. It speaks the language of pretty much every major broadcast standard. The base model is QAM, but the system itself can handle what? DVB-A2, satellite, ATSC, DVB-T, the whole list.
A whole 9 yards. ISDBT as well.
But if it's translating all those different standards, does the signal take a performance hit? I mean, speed has to be a factor.
You'd think so, but no, not at all. This flexibility is paired with critically high performance. We're talking about really low latency.
How low?
Between 10 and 20 milliseconds. And if you think about why that matters, I mean, that's a vital number. If you're in a sports bar, you just can't have the video lagging behind the audio from the speakers.
Right, or the digital signage is a second late. That would be a mess.
It makes it a seamless experience. That low latency ensures it's all happening in real time.
Okay, so let's dive into the digital side. How do the signals actually leave the box and get onto your network?
Well, once the video is converted to IP, it can be streamed out in a couple of ways. One is as an MPTS, that's a multiple program transport stream.
And the other?
The other, and this is where it gets really smart, is optionally as an SPTS, a single program transport stream.
Okay, MPTS, SPTS. What's the practical difference for someone designing a system?
It's a huge advantage. SPTS gives you surgical control over your bandwidth. MPTS just grabs the whole bundled channel, everything inside that single frequency.
The whole fire hose.
Exactly. But SPTS lets you digitally kind of snip out just one specific subchannel from that bundle and stream only that program. You get precise control over what's using up your network bandwidth.
And I assume it handles all the little details, too, the things that make it look professional?
Oh, yeah. Things like closed captions, all the necessary audio codecs from AC3 Dolby to AAC. And the entire system is managed through a standard web browser, which makes it, manageable for the operations team.
So when we put it all together, what does this all mean? This device acts as a sort of central brain, a powerful head-end piece that bridges that gap between old-school cable and modern IP networks.
It simplifies everything.
Yeah, it simplifies channel management, handles all the video and audio standards in one box. It's really the definition of future-proofing your existing gear.
And if we connect this to the bigger picture, the ability to just effortlessly mix and match global RF standards, DVB-T, ATSC, QAM, and instantly convert them to these low-latency IP streams, it raises a really important question.
Which is,
well, as broadcasting continues to migrate online, does a single, powerful, universal translator like this ensure that all that legacy broadcast infrastructure, that it actually remains essential in the future, simply because this tool makes the transition so painless, something for you to chew on?